Okay, so here we have number 25 in chapter 9, which is the torque section. I'm going to start by listing my givens. That would be the weight of the person, R1 and R2. And then we have to find the normal force in each hand and the normal force in each foot. Alright, so after drawing the sketch, now we have to draw the free body diagram. Find blue. Okay, so there would be normal force of the hands, normal force of the feet, and then this is the center of gravity, so that's where the weight of the person would go. Alright, so after this point, we ask ourselves, is this in static equilibrium? Yes, it is, because he's not moving. And we have to choose an axis of rotation. So really the axis of rotation, you choose it wherever, or you place it where you can get rid of an unknown. Normal force of the feet would be an unknown, and same with the normal force of the hand. I'm just going to put it here so we only deal with the hand, so I can try to find the normal force of the hands first, because we already know the weight of the person. Okay, lastly is we apply the conditions of static equilibrium. So this would be that the sum of the torques are going to equal 0. You can also rewrite this as the clockwise torques minus the counterclockwise equal 0. And we can just rewrite this as that the clockwise are going to equal the counterclockwise. Oops, I rewrote this. Wait. Sorry, counterclockwise equals 0. And so yeah, clockwise are basically just going to equal the counterclockwise. Now what I mean by this, by clockwise and counterclockwise, is if these forces, since this is the axis of rotation, these forces would act. These forces would be acting in a certain direction, either counterclockwise or clockwise. So if this were going down, the weight of the person along this axis of rotation, it would be moving in a clockwise direction, and the normal force of the hands would be moving in a counterclockwise, like that. So now we just have to, now all we have to do is substitute these guys in, here we go, is substitute these guys in. So the clockwise would be the weight of the person is going to equal the normal force of the hands. At this point, we have to rewrite weight of the person and normal force, because torque, and this is in general, torque is going to equal R, which is the distance from the axis of rotation to where the force is applied. So this is where the force is applied. Here's the axis of rotation. This would be R1, and then this would be R1 plus R2 for the normal force of the hands. And then times the force times sine of theta, where theta is going to be the angle between the force vector and the lever arm, which in this case would be these guys over here, right there. Alright, so now we're going to go back to where we were. So we're going to rewrite these each as weight of the person times R1 times sine of 90 minus theta, and it's 90 minus theta just because we can tell, okay, it's theta, okay, yeah, we get it, equals normal force of the hands times R1 plus R2 times sine of 90 minus theta again. Alright, so at this point it's pretty easy to see that we have sine of 90 minus theta on each side. So we can go ahead and cross these guys out. We're left with weight of the person, R1, equals normal force of the hands, R1 plus R2. Since we're looking for this guy, let's see if we already know everything else pretty much. We know this. Yes, 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 yes. So at this point, all we really have to do is say weight of the person times R1 over R1 plus R2 is going to equal the normal force of the hands. Now, this isn't really the complete answer, because once we get this number, we have to find the normal force of each hand. So all we have to do is divide this guy by 2 after we get it. Alright, so that was part A. Now what we have to do is find the other normal force. The easiest way to do this is really just sum of the forces. Okay, so we have, so by now we kind of have, all we really have to do, we just have these, it's really just these three forces, so we're going to add them up in the y direction, and we'll see. Okay, so we're almost finished, but now we can do, let's choose this. So now we're just left with sum of the forces in the y equal MAY. This goes away, goes to 0 because it's in equilibrium. But now we know normal force of the hands plus normal force of the feet minus the weight of the person are going to equal 0. And it's pretty straightforward at this point, because now it's just normal force. We know these guys, so it's just normal force of the hands equal weight of the person minus the normal force, normal force of the feet equal weight of the person minus normal force of the hands. And again, at this point, once you find the normal force of the hands, you just have to divide once you find the normal force of the feet, you just divide this by 2 to get each individual normal force of each individual foot. Just a little recap. We started out. All right, so we started out kind of with our free body diagram here, labeling the system was the body, or was the entire person. We got normal force of each of these hands, feet, the weight of the person. We had to make sure we knew which direction the forces were acting, so either counterclockwise or clockwise. We used torque equals RF sine theta. So we kind of plugged in everything we had here. The angles ended up canceling because they were the same, which again 90 minus theta, then from here it was pretty straightforward, and then again just did some of the forces to get the last normal force. Okay, so the one thing I just wanted to make sure to show, because this is really the important stuff, at least when it comes to torque. Everything else is relatively similar to what we've done before, and that's, again, I just want to stress this again, that remember this guy and the fact that some of the torques are going to equal 0, and these are the kind of these conditions, and kind of just this is pretty easy. These are pretty easy to see which way they're going, that the forces would be acting, axis of rotation, all that stuff. But these are kind of the key guys to remember with torque problems. If you have any questions, you can ask me or Alexa or Andrea, who are in this torque wiki also.